Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hello, I'm Ed.
And, you don't hear John with us this week. He had some stuff going on with school, and, we're going to let him do that. I think he said he had a team meeting or something like that he was doing. Working on that master's degree. Usually that's why I put my meetings on Fridays. But, some teams are used to work with. So as we kind of go through and we really kind of see, what's going on, across the industry, for example, like last week we talked about vertical integration. And what we kind of want to do is circle to, kind of the bottom of that chain, I guess you could say. And where we start talking about Industry 4.0 and robotics. So we start really getting, or, if we really want to go even deeper, it's the robotic life cycle and stuff like that. So that's when you really start getting into the use of, cobots, robots, AGVs, kind of working in harmony and, sending data via MQTT systems to, all other subsystems up the chain, giving actual, good old support for, preventive maintenance and also, elongated troubleshooting if there's a need, or also, part blocking, so we can actually block sets of parts that we've produced because of errors and differences in the system. So when we're thinking about that, Ed, what are you thinking?
So when you start talking Industry 4.0, one of the things you look at is, yes, we're using at the field level more smart sensors or intelligent sensors and actuators, but the goal is from the shop floor, you're trying to get real-time data to make decisions. So it could be that something from a predictive or preventive maintenance point of view, where there's a PM, TPM program where you have an app that communicates directly via your SCADA system that tells the technician in real time, hey, we're having these type of faults as a warning, so it's not an actual alarm.
Right.
And this potentially could lead to downtime. So then you can strategize, how do we attack this? Maybe it's a application where you're using two different types. Say maybe it's a product A and a product B. And right now we're running product A, but the problem's with product B. So we can block out that side of the line, do the work while we're running product A, and that gives us some flexibility. Or we can say, hey, well, we can try to schedule this for a lunch. So maybe we have a time frame that we can do it during a lunch, or maybe it's something we just have to monitor until the weekend, where we can have an extended amount of time to repair those things. But you would get this information in real time, so
right.
you would not wait for a till failure of it.
Right.
It would give you this information, in advance.
You got me really thinking on a lot of things right now. Because, and this is kind of where it gets kind of fun, because the thing is when you start talking about Industry 4.0 and robotics, especially, or the robotic infrastructure, I guess you could say, is that it's still the wild, wild west. We really haven't got to the point where somebody said, this is what Industry 4.0 is going to look like at the operational level. This is what Industry 4.0 is going to look like at this level. This is what Industry 5.0 is going to aim for. No one knows that yet. We're not even there yet. But because what I'm thinking is when we start seeing this type of stuff is, we are running a SCADA. You're going to have to, or some sort of version thereof. However, is say you have countdown clocks on your ERP system, your maintenance ERP system, right? So every cycle count of, an actuator or something like that will send a message via MQTT through the SCADA into the ERP system and activate that countdown clock. One every cycle knocks down one, right? Because then you can see in real time, you can have real time dashboards telling you what your maintenance schedule is looking like on real time dashboards set by the time that you set. It says, okay, I am, 5 days away from having to do a valve PM, or I'm 6 days away from this based on cycle count.
And that can also be done on. Normally, we don't do necessarily on cycle.
Yeah.
Some things normally are not done on cycle. Mm-hmm. Most is done on time intervals. So you would say, hey, based on the manufacturer's recommendation, they say every 30 days, every 90 days, or quarterly, or annually, you should do blah blah blah. Now you can use a working clock.
Yeah.
And you don't necessarily have to send like you don't have to use a polling method. Mm-hmm. You can do something called a unified namespace, and basically you do all of that polling you're talking about in the PLC, and when the PLC reaches that event, send that information to it.
Yeah.
So it's an efficiency thing. Mm-hmm. So instead of sending something every cycle, I can still monitor that inside at the automation level. Mm-hmm. And when the automation level reaches an event, we trigger that MQT event. In that unified namespace, or if you want to use OPC UA, whatever you want to use, you trigger it and say, hey, send this to the next level. Right. And then the next level can automatically say, hey, send the job required to be done this weekend, send the PMs come and do this weekend to an application on a smart device.
Yeah. And the thing is for me, and I think I'm right there with you, that whatever makes it easier for the technician to know that they have to get to the floor, and not even get to the floor and go check, but be prepared for what's coming up, because we both know that how many times somebody says, "Oh, I'm going to PM this thing," it never gets done, and you wait and you wait and you wait and you wait until you have a failure event. And the one good thing about using any type of MQTT monitoring for anything is now I have a trend. I have trend analysis. Mm-hmm. I can see what my trend looks like until it breaks and say, okay, cool, I was due for a PM right here. So I'm not actually validating my process. We're going through the process, or hey, it broke before PM. What happened? And then now you can go back and kind of see kind of what's going on, stuff like that. But like you said, freaking having things go to a smart device in the palm of the hand of the individual is something that I think is, next level. But it's also, and this is where, I kind of, see things going eventually, is the removal, almost removal, of the HMIs. And you're going to a tablet-based HMI system. You walk up, you scan a barcode, your tablet pops up on the HMI pops up on your tablet. And if you have to do anything, you go to a main PC. And it gets that stuff off the floor. It also reduces an entry point of any type of cybersecurity attack, because guess what? It doesn't exist. Yeah. You can't have somebody charging their phone in the freaking HDMI port anymore. Right. But now here is where, I kind of look at it a different way also, is I take a screen, a small, and I replace my HMI screen with a information board for the cell, a health information board for the cell that tells me exactly by walking by what is going on in that cell. If I don't have my phone or a tablet or a laptop on me, I can look over and see exactly what the health of that cell is and say, okay, cool, we're okay today. Or we might want to start thinking of something. Yeah. But that's just me, but thinking kind of at an efficiency level.
I mean, it's something that'll probably happen in the future. I mean, right now, just because the infrastructure's in place. Mm-hmm. New factories may take that approach. Yeah. But in general, I mean, it's no different than being in an airport and looking at a terminal for which flights are due or which gates you got to go to and so forth. So
You can monitoring software. We can actually use the old school freaking the flight roll down, click, 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 click. Hey, I'll buy one.
Yeah. So, I mean, I think that if we're talking about robotics and we're saying what we want to do with Industry 4.0, and it's not just like I said, we don't necessarily have to send data directly to the polling. It's old school.
Right.
It's what we did. It's what we had to do with the technology.
Job writing. Yeah.
You know, now it's event driven.
Right.
And it should be event driven. The reason you want to do that is bandwidth.
Right.
And then why would you want to poll something 1,000 times that has no influence on your throughput? Mm-hmm. So you could have a historian in addition to when we was talking about that unified namespace. Right. And from that historian, when you reach a trigger level, or if you want to see what's happening in real time, then mm-hmm. Even if you want to, you say, hey, after I get 20 events, hey, I want to plot. Right. For every 20 events that's stored in the historian, mm-hmm. based on the criteria that I set up, right. If then, right. Then you would trigger, and instead of doing polling. So this is what 4.0 is doing. And it's instead of going from, it's not a ladder approach. Right. It's here's the information. Whoever wants the information can access it whenever they want to. Before, it had to go up the stack.
Right. And like the for example, the 4.0 systems that, I've kind of been working on, kind of been doing the same thing you're talking about, is, we create our data lake, and then, we do a 15-minute, we do a 2-hour, a 10-hour, 1 day process where we have a job that runs using Node-RED to pull that data into a KPI-based tracking system so we can monitor buffer level and stuff like that.
Like I said, it's an interval.
Right.
Intervals are better than polling 1,000 things that's not correlated. Mm-hmm. You can even at that historian level, or even at that UNC, you could have another level to process the data, to format it to wherever you want to, that pre-does most of the calculations. So, hey, I want a level that I can have offset over here that's doing my MI AI. No, excuse me, my ML AI, my machine learning and my AI. Mm-hmm. So now I can also get this dialed in to a point that we know that this here, yes, it's a nuisance fault. Right. And now we can start to understand, are we able to eliminate the nuisance fault?
Can we do a
if
trend
not, what is the consequences of this nuisance fault? Mm-hmm. Is this just something that comes with that technology or this particular robot? Or is it something that we did in our application of that robot that we have to live with because we made this choice?
Right.
So why should we look at something unless we know if this and this, the nuisance and this happened, then there's something else going on.
Right.
So now that nuisance became an actual problem. Mm-hmm. So I mean, you can do all that at the lower levels, mm-hmm. and allow your higher level systems to just, when this event happens, with MQTT, mm-hmm. hey, send me what I requested for. Yep. Send me the request.
And two of the best systems for that type of analysis at that level, as far as systems which give the administrator, gives the technician, if they're experienced enough, a lot of high level growth and vision on that type of stuff, is digging into the Elk stack, into Kibana and stuff like that, because it saves your MQTT messages as flat files. Meaning that now you can go back and you can break down every little topic thread of every single message. So now you can start seeing, okay, cool, like you said, your nuisance fault. Is it just recently changed to a nuisance fault? Did I go from a warning to an error? Or did I go from an error to a moment? And the thing is with that, we hook up Node-RED to extract that data and send it off to its respective destination.
So when I say nuisance fault, I'll give you an example. Most people do a poor job with their alarm philosophy.
You don't say.
They have a message level, which is essentially, hey, here's a It's like, hey, I'm telling you that's blue.
Yeah.
Then you have a warning. Then you have an actual fault, and then it could be a fault 1 or a fault 2.
Right.
For me, in a alarm philosophy, anything that causes a line stoppage should have the highest priority in your alarming philosophy.
Yeah, it's a fault
The
1.
Other things from a warning point of view should strictly be, hey, this is a warning. This is happening. Something is abnormal. We are outside of working parameters. Those should be the 2 priorities. The other things should not spam 100 times. If you're saying, hey, my PM is due, if the check engine light is on, that should not spam the system so much.
Right.
It should say, hey, I'm going to stop the line when you reach this hour clock.
Yeah, I agree with it.
Stop. So if I'm telling you, in 2 shifts, I'm stopping the line till you do this PM.
Right. And the thing is if we implement the Industry 4.0 robot monitoring philosophy, the technician's going to get a text message, the management's going to get a text message, everybody and their grandmother's going to get a text message that says, hey, your PM's here. Here's my document. Please fill me out, and can you please check me? I'm not feeling well. It's telling you it needs a checkup. It's not going to be spitting out information because it doesn't need something. And like you said, that like monitoring, philosophy, we have the same problem in IT systems. Jesus. People don't know the difference between what is a warning, what is an error, and what is just a bygone log file. Mm-hmm. And sometimes when you read it, it's like, no, that's actually a fault. That's a problem. That's broken.
But now here's where Industry 4.0 should show itself.
Right.
It should prioritize that, and I should not have to have a subject matter expert to try to cipher what it's telling me. If it's a log, it goes to the log, and you have to physically go to the log.
Right.
If it's like you said, hey, something weird's going on here, throw a flag. So you should have flags, and then if it's a damn, hey, Houston, we have a problem. Yeah. It needs to be a Houston, we have a problem.
Yeah.
So I'm saying, like, it's a philosophy thing.
Exactly. I agree with that.
With polling, everybody wanted every message in DDE and all of these Modbus and I'm gonna say all these old protocols.
Oh yeah.
It was a polling system.
Right.
And every so many whatever milliseconds, you was polling the system for every damn alarm that generated or every piece of information. With Industry 4.0, at the level when we say we got a robot that's equipped with MQTT, it has intelligence built in it, it has some ML and AI, it should be able to understand what your alarm philosophy is, and no matter what nut go over here and program 1,000 alarms in the PLC, the robot could care less. Because the robot say, hey, all I need from you, I need an interlock. I need signal. I need signal 1, signal 2, signal 3. Hey, I'm giving you back signal 1, signal 2, signal 3. Thank you, cop. Thank you, police. Traffic light. Appreciate traffic light. You green. Quit talking to me. Yeah. So I'm saying that's what Industry 4.0 will do with robots.
Oh yeah. And the thing is for me. By the way, I think we know the same guy. Believe me, I've got his messages. But when we start talking about, especially like what you said, log spamming, warning spamming, everything spamming, it's like, okay, guys, do we really need this? But the thing is using MQTT to your advantage and using Industry 4.0 to your advantage means I do not have to have a robot expert on staff 24/7, 365. And the thing is, what that means is now you entrust the guy at the lowest level denominator to understand what is going on. And the one thing I cannot stand is when people build in the fault messages into some of these robots, and you have to be a PhD level freaking engineer to figure out what the hell they meant. And my thing is you start getting times where it's like, hey, did we forget what the KISS methodology is? Keep it simple, stupid. It is broke. I know. Tell me why it's broke.
And some of it is jargon too.
Right.
I mean, not to interrupt you, but some of it's jargon.
And
we're used to talking in jargon.
Right. And the thing is here's where I also believe in a little bit of karma. If you're the one who programmed the fault messages and you over-programmed it, you're the first one for the first 6 months to get all this crap. Because guess what? You're going to learn real quick that you might have put a little bit too much.
But and we're basically talking about robots today. I mean, there's other platforms, other technologies, and we're not getting into that. But with the robot, it based on the parameters you give it, to learn, it learns what we just said. The robot is the SME.
Right.
The human is the person that has to come when the robot can't make a decision. And then that human, that tech, will probably be the person that has to change a mechanical component, an electrical component, something of that nature. Right. But that person should become an analyst, and the analyst should be able to take the data.
Right.
Now, here's another thing where I think Industry 4.0 with robotics in particular would be a game changer is configuration awareness.
Yeah.
If I plug in a new device, the system knows how to detect what that board is because I have intelligence on the board. I have intelligence inside the robot that knows, hey, last known configuration. I mean, we hate on Windows, but I do like last known good configuration.
Yeah. And, the thing is this is where, the company like Robotics came up with the thought process of not making cobots, but making collaborative robots, right? So they deleted the entire notion of what is a cobot. They deleted the entire notion of what the hell a robot is, to be honest with you. And they made robots that have ML built into them, AI built into them, cameras built into them, touch point programming built into them. But they're still in a cobot form, right? But if you were to take that collaborativeness of that robot, integrate that into a full-fledged, full-blown, industrial robot, you have all of that computing power on board that's doing all that analysis in real time to tell you that, hey, guess what? We've got an ouchie going on here. Or, hey, that I might be a little bit too warm, based off of this is going to happen every day.
Some of those things are already built into the robots. It has some. So say the robot vitals.
Right.
They're intelligent enough now with robot vitals that if certain things happen, the robots stop. Right. So for example, we got safe zone for robots. For example, if the oil temperature goes to a certain temperature, if it goes to a position that says that, hey, I am at a 0 position and it's off by so many revolutions, it knows, okay, hey, I'm out of calibration. So they built that into the robot. So far as from a health point of view, where, hey, we're at the point of a catastrophic failure, the robots are there. Where the robot is not there it's still hard to replace the human at this point because the human has to sometimes help the robot understand when it's a tie. Right.
And, and I think that, we're slowly but surely getting to what people like to call lights out production. We're slowly but surely getting to the point of where stations can be mag fed. They can be, and then they can produce on their own. Meaning AGVs do all the parts. It's about that. You may have limited production people inside the building, and very limited. And all maintenance does is watch a couple boards and see what the robot's health is doing.
Or they'll be in a control room with a SCADA system, and from the SCADA system, the same thing you do in a nuclear plant, the same thing you do in a chemical plant, the same thing you do with petroleum.
And the thing is, you start dealing with systems like ignition and stuff like that. And the thing is when we start talking about lights out production, I'm talking about at night. I'm talking about only running 2-shift production instead of 3-shift production. And, have the humans running and loading during the day, have the robots loading themselves at night. The thing is that's where you start doing, which this is where for, us IT people and, us engineering side of the house, we get to have a little bit more fun. Because now you're talking about, hey, guess what? I've hit a minimum level in my magazine. So let me go ahead and auto reorder via MQT to an AGV that takes that preloaded pallet to the freaking to the magazine. Once it's in position, it sends a trigger to a cobot. That cobot now knows, or that robot, if you're using a full-blown robot, knows to start picking parts off of the AGV and loading them into the magazine system. And then once it's done loading, it triggers the AGV to go back. So the thing is now you start really dealing with complex Industry 4.0 cell builds, which for some people it seems complex. For other people it seems like, oh, that's music to the ears for some people. But it's also leveraging the technology that you have. Because the thing is how do I know that AGV is in place? Okay, cool. I got a 6 scanner that picks the target position that tells me it's in that position. Or the AGV arrives at the coordinates, it fires off a thing, says, hey, I've made it to the GPS coordinates that you gave me, and now I'm ready to go.
Or you have your own global production system that knows exactly. Each one has Wi-Fi.
Yeah.
You can have access points. Each time it gets in that area, I know exactly where it's in that area.
Yep.
But you can also use things like technical availability at the line to predetermine, hey, well, we know after running an hour, we're going to need parts because we're building so many parts per, so many jobs per second. So based on jobs per second, it's based on technical availability, based on uptime and all those type of things. All that stuff can be calculated at those technologies you talked about and send these requests, however you want to send it, however you want to track it. You can do it by sensor, 6 scanner, whatever you want to use to do that.
And the thing is you also get to the points of where people can't see everything. It's just how it goes. They might miss something on a SCADA system, or whatnot. So this is where it turns into, right now it's, daydreaming, but it's more or less stuff that's plausible. Is if I have a major downtime situation at a robot at night during lights out production, is I have pre-set up crash cards, AGV crash cards, that as soon as a downtime event happens, that AGV crash card is activated with the tools on board, the light comes on, and off it heads to its to the robot location, already indicating to the technician that, hey, now I have to go follow that darn thing because now there's a problem. And because the thing is how many times do we get technicians that are playing Where's Waldo looking for the orange robot in the middle of the room? Yeah. So why can't we let the AGVs also help out the technician by bringing the parts that might be needed, that might be bringing the tools that they may need to keep them from having to lift it? And then when they get there, they know that, okay, cool, this is what's going on. They can read the diagnosis from the machine as they're walking to the machine to fix it. By the time they get there, they're aware of it. They're not gathering their parts anymore or their tools, and they get there, they're more prepared.
Yeah. So one thing you can do is you can make the job box an AGV.
Yeah.
I wouldn't necessarily use anything that's doing my milk run
for
that type of application, but yeah, it's possible you could have a job box that's an AGV, for that line, and it can go to a destination that we say, hey, this is where the job box is supposed to be, and the job box goes where it's supposed to be before, based on, hey, I have a downtime event, and it's there before the tech gets there. Also, then, maybe even we go back to old school and have air chutes, where we can have parts that come from a supply building that automatically send those parts and have the parts there based on, hey, this is what we had. The last time we had this, here were the things we used to repair it. Yeah. And of course, you would just say, hey, we know that typically if a robot crashed, that we're going to need the crash car for repairing details. So
right.
We know that should be there regardless. Sensors not making, maybe you have a vending machine that's already there, on site, where you can have these sensors, common sensors that go bad in a vending machine. And that vending machine, once you do the ML, AI, deep learning, once you do all these things and we understand what happens in this event, and we know that this is the thing that causes the event. Yeah. So when you go
to trend analysis.
Yes. But when you go to a doctor, and you say, hey, I believe I have COVID. The doctor does a test. He looks at the results. It's yes, you have COVID. No, you don't have COVID.
Right.
Based on yes, you have COVID. Here's the recommendations. No, you don't have COVID. You may just have something going on with allergies. So this is, so that could be the same type of logic or intelligence you embed at that level with the robot, so that the robot only during a event, not polling, when it has an event and it is 100% said, hey, I'm stopping.
Yeah, I have a boo-boo. Come fix me.
Here's everything that happened. This alarm happened first. This alarm happened first. What normally happens? Blah blah blah. And it has a tree, decision tree that it goes through. Bam 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 bam. Bam.
Yeah, triage.
It checked everything down that decision tree. Oh, it's this.
Yeah, it gives you the triage level automatically.
Yeah.
And the thing is that's when a lot of this stuff can be built into the crash carts. Because if you think about it, if I have a crash cart, I've got a tablet built in my crash cart that's got a scanner attached to it. I have all my known spare parts, the belts, sensors, screws, bolts, washers.
So basically it's tied to SAP.
Right. So if I get there, I need this, scan. And the thing is, and they're already on the crash cart.
Well, we shouldn't have to scan.
Right.
If we're using Industry 4.0, we can scan. We can scan.
You can. But you can also do it based off of if I open that door, I automatically remove this. You can also do which is where I would probably want to try to build a job box like this, so don't let this one leave my head, is I have a job box. I have an issue that pops up on a robot, and I say, okay, cool, hey, it's having a problem with this sensor. I hit the sensor button on my tablet, and it's a pick by light system. It lights up the door. I open the door. There's my sensor. The spot where that sensor is, I reach in, I pick up the sensor, and then once I close that door, it automatically deducts that one from the system. Even if I don't take the sensor out, it still deducts one, knowing that now I have to go back and investigate that. Because now we've gone to a pick by system built into a job box. And the thing is you can have all this stuff set up for triage. So I need this, this, and this, and have it automatically auto light up the lights based on order of preference. And, so once you open them up, you grab your part and go. You don't even have to type anything in. You just say, hey, guess what? I've got this problem. Starts lighting up parts. And so you go from a logistics pick by light system to a maintenance pick by light system. That now, when they get there, it's easier for them to find their parts, because the last thing everybody likes doing is walking to a job box that you were not using before. You open it up and go,
But it should also be. So
where'd that go?
Because
everybody can never find the 10 mil. So,
So here's the thing. Like I said, in SAP, you're capturing what parts are being pulled out.
Right.
Also, SAP, you don't have to use SAP. You can use your own system.
Yeah, SAP will bankrupt you when you install it, though.
What is it, CMMS? You can use your own CMMS system, whatever it is.
Yeah.
That system is already knows what materials you use.
Right.
That system already knows the interval of TPMs and PMs. That system also has a history of all of those things, and it's tied to your inventory system.
Right.
So that system knows when the count goes down. What you do with that system, if we talk in Industry 4.0, is outside of the robot, is now I can offset that to a historian.
Right.
The historian can communicate with the robot.
Right.
And then you don't use processing power from the robot. You offset that to a historian, and when an event happens that's triggered by the robot, access the historian and tell me what happened the last time this happened.
Right.
And then that information can be given to the robot. The robot can give it to the job box, so that it already knows ahead of time. The job box can send the information to a smart device. The technician know before he get there. You can even use vision systems or a camera just to say, "Hey, this is what it looks like," and the guy can be on route.
Right.
So for me, the systems
we're building silos right now.
Yes, that's data. That's intelligent silos.
Yeah.
That's exactly that's the approach. 100%.
And the thing is the silo data is good for certain things. However, we need to start intertwining a lot of these systems and a lot of this data and documentation, because, for example, like if you talk about a job box, and we keep going back to job box because the thing is, the job box idea is probably one of the more interesting things that pops up, because half the time you always hear technicians go, "Well, I can't find anything." Okay. Well, why did it take you so long? Well, I couldn't find this. Well, I'm sorry you couldn't find the 10 mil. Suck it up, Buttercup. Carry one. But the thing is what I would do, honestly, is you walk up, you have a job box destined for that line. It has a list of all the stuff that, once it comes to a certain area, it uses geolocation to tell you what faults are in your area. You pick the station you're in, or you open up that station, it tells you exactly what's going on that you already have on your tab on your walk up. As soon as okay, cool, I'm here, I'm diagnosing this issue. Okay, cool, these are the parts you're going to need.
Yeah.
And then, so now we're not even pulling the robot issues anymore. We're pulling out of our data silo and saying, hey, I've got this, here's the parts you're going to need for it, congratulations. But the thing is, at that same time, the system should automatically mark that as a PM. Automatically.
Or verify at SAP.
Right.
When was it last done?
Right.
What was done in the PM? Is the PM efficient enough?
Right.
Do we need to evaluate the PM because we missed something?
And I think that should go to the device. I think that should go to the handheld. As somebody's walking up, they can look at the history of the PMs and the fixes that's been on this robot.
Yeah, so they can be a viewer, but
Right.
SAP is the
the SAP is always the master.
It's the intelligence. So
Yeah.
SAP should get the intelligence, put it in a format that the person understand a work order. Hey, TPM required, PM required,
Right, exactly.
blah, 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 blah. Hey, I need for you to do an audit of this PM and tell me if all the things that we have in this PM is correct. Do we need to add something to it? Should we add pictures? Should we add a QR code? Should we add, hey, we need to verify the job box that's tied to the AGV has all the things we need to complete this particular job.
Right.
And it should be event driven, based on those things, based on the ML, AI, deep learning at each of those smart. And in general, the tablet is probably going away.
Yeah.
We'll probably have a phone in the future that's big enough that you can turn this
We already
way.
got one like that.
And then you'll probably have smart devices,
Yeah.
wearable intelligence or wearable technology. It's where the future is probably going.
Right. And, the thing is I really see that, that in the near future, SAP is going to go away. SAP as the standard will go away. And the reason why I say that, especially for Industry 4.0, especially when you start dealing with robotics and stuff like that, I think SAP as a standard is going to disappear. Why? SAP is extremely expensive to install. One ERP is extremely expensive to install.
Well, I mean,
But
it'll probably go, like you said, it'll go cloud-based eventually.
Even then, it's still expensive.
No.
But
cloud-based, we use edge computing.
Yeah,
You
but-
have an API. All you're doing is accessing the API.
Well, here's the thing. I think we're going to see more of the grassroots people come out and build their own. I think we're going to start seeing people who don't like what SAP has to offer as far as systems of record, and they decide to build their own. I think we're going to see a lot of people start building a lot of things out of the Azure cloud, and we're going to start seeing people build a lot of stuff out of the Amazon cloud. So I think as people leverage Industry 4.0 and we leverage smart robotics, we leverage the the collaborative robots and the AGVs and stuff like that, I think we're going to start seeing a SAP derivative that is data siloed based, that is more user friendly, that is more event driven, and that's not as, I guess you could say, rigid as some other things. Because the thing is SAP is really only used by major corporations. If it's a mom and pop organization, they build their own SAP like system, or if it's a small company making their own SAP like system, then we kind of go through and see that, every little bit, every little thing that they do is kind of tied back to the system, and we don't have to worry about SAP anymore at those smaller level echelons, lower level echelons.
So SAP is just a brand name,
right? Exactly.
As far as that technology, they're going to leverage the same way everybody else is. So I mean, it doesn't matter if it's a commercial version. I mean, but the reason people use that is because it's a system that works.
Right, exactly.
It's say it if we talking
it's a system
a
of
large
record.
factory.
Yeah, system of
Most
record.
large factory. There are other systems that in place that can do the same thing. There are. You can make your own, but I think you're probably going to have to look at something with that mirrors what APIs do for Windows.
Right.
It doesn't have to be API, but I think you're going to have modules, some kind of way that you can access, or libraries. Hey, this library is pre-built. I'm just taking this library to build what I want from it.
Right.
I'm automating this stuff so I don't have to manually do it, and I'm accessing this stuff from cloud, my own personal cloud, or however you want to do that. But those things should be ML, AI, and deep learning.
Right. And I think we saw a lot of, when we were at South Tech, we saw a lot of these high level non-SAP ERP systems that are game changing. As far as for larger corporations and maintenance driven organizations that are dealing with subtractive manufacturing, additive manufacturing, and robotics. Because why? They're built to the process. And I think that is where big SAP as a object of choice is not really the greatest for certain things. And you start dealing with the ERP systems that are built for the job at hand.
Yeah.
They're built for that environment.
You can get what's customized for a smaller business,
Right.
But in general, the reason we use SAP, reason we use Windows, the reason we use Linux for certain things,
Right.
There's a track record.
Exactly.
In large
organizations, exactly.
Large manufacturing. I want to make sure.
Yeah. Well, we're definitely prefacing that.
Yeah.
Because I'll say this: I will not, and continue not to recommend SAP for lower level companies. For anybody who's not a multi-billion-dollar organization, do not buy SAP.
Yep.
Please don't build, because guess what? You won't exist very much longer.
Nope.
Go out and look at one of these ERP companies that are building industry-specific ERP and use them. Some of them will say, hey, guess what? We'll talk to SAP. Okay. Guess what? Talk to SAP for a parent company or for a supplier or something like that, and get all my orders in from SAP from a supplier. I don't have to have SAP on site.
I mean, I'm all for edge computing. I'm all for cloud computing.
Right.
I'm all for those type of things. But there's a but. You always have to be careful when you start to put everything outside the gate.
Right.
If you put the gold bars outside the gate, then someone's may come by and pick up the gold bars.
So we don't leave them in the bed of a truck.
So we probably should do that with a redundancy plan in place, that if this happens, I have another, I'm not just with one supplier.
Right.
Not just AWS, not just Azure. I
Right.
have other solutions in place. I have it containerized. I have it virtualized. I have it, I have it blocked in where even if something happened, worst case, I have a doomsday plan.
Yeah. Hybrid cloud with storage on site.
Yeah.
And then the thing is now you have the deep storage and stuff like that if you want to go that way. Hell, now they even have submerged storage. That's a whole another bag of animals.
Yeah.
If you haven't heard about that, they're Mobile One's making oil that you can submerge servers into and run servers out of Mobile One oil. And they won't short out, won't short circuit, nothing. They'll just run by themselves.
Yeah, the general electronics and oil is okay.
But that's
Generally, it depends on the conductivity.
Yeah.
I have seen an experiment before where you've had purified water, and you're able to take high voltage and place it in the water. It's the impurities in the water that makes the ability for the current to flow.
And so that's definitely a squirrel moment that we could definitely go down that rabbit hole. But the big thing is, now I'm going to throw this out there, if you had to build what would be known as, say, your the brain of Ed, how would you design a system, Industry 4.0, robotic monitoring system, if you can start with a clean slate with the robot, any sensors you want, and the software you need?
So for me, why Lego is proven that they have a lot of experience building Lego blocks. So I don't need to do anything with making the Lego blocks.
Right.
The robots are there. The technology is there. I don't necessarily have to have that system in the robot. What I need to have from the robot is a way for that system to be accessed. So for me, I'm having silos. I'm not putting any of this stuff on the robot. It makes no sense to put that on top of a layer. What makes sense is give it the ability to make decisions and access that data. That data should be collected throughout the whole system, in particular the robot, to an historian. And then from the historian, and it's event driven. I'm not polling anything. That's 1980s. You're wasting bandwidth. You're doing dial-up. We're past dial-up now. No need to poll anymore.
I mean, I don't have to pull the stuff off the side of my
So
printer
for
anymore?
me, what I would do was to have a system that is, I would want to have the ability to make a dashboard. So dashboards and KPIs. So a dashboard for the user, but KPIs for the robot.
Yeah.
The robot knows what is expected of him.
Right. Yeah, no, I
As far
like
as ML, AI, decision, deep learning.
Right.
Hey, I expect that when this happens, you tell me what's happening.
Yeah.
And all the data that you can give me that relate to that. And you know what's a real alarm and a warning.
Right.
So the alarm philosophy will be built in that layer. I would build in my alarm philosophy. I would build in the way I'm going to handle data. I would build in the learning for the robot. I would build in how to give information for the next gen. So I need next gen data for the next robot.
Right. Makes sense.
These are the things I would be doing. How do I get you to Industry 5.0? What things do you see that you've encountered? What data can we take from you to improve on the next iteration of this robot? Those are things I would do.
Makes sense. I actually like that idea. For me, it's I don't mind silos. I really don't, and I believe in data off product. I believe that we have a hard drive on board these robots, on board these robot controllers. That if anything, all they should have on board is a configuration file. They should be offloading everything. And I mean everything. And like you said, have the ability for the robot to go up and look at it, say, hey, okay, cool, this is what's going on. Woo, that's wrong. But the thing is I also believe that we should have some little bit of machine-to-machine communication.
Yep.
So meaning that if a gripper on a robot notices, oh, this is a little bit out of whack, it tells the robot next to it and says, hey, guess what? A little out of whack here. And kind of gives them the idea of, hey, or gives it whatever wherever the problem is, and say, this is what I've got. It's a little bit out of whack, just as a heads up so you don't crash. So it kind of gives it a little bit more advanced crash avoidance.
So that exists now with safe zones.
Yeah.
So it knows that one robot can't move before the
No,
other
but no.
robot.
What I mean, I don't mean like that type of crash avoidance. I mean like if your part. Sometimes you have a part that's not completely in round, and it's somewhat out of, kind of out of bend, or there's a bent corner on something like that. It knows it can see that, feel that, and let the robot next to it know that, hey, guess what? There's a defect in this particular area. So when you go to grab it, just be aware that it's there.
Yeah, I mean,
but the thing is, so
you can do that in the future. The only problem right now is
we don't know.
How do you would have to have a show position, or you would have to have a vision system so good that it can tell the deviation, because the robot, even with the gripper, doesn't have that level of sensors in it to know I'm off. It's basically it's sensors that can be smart, but they're not you would have to go with sensors that understand a deviation.
Right.
You would have to have a smart sensor, a
Right.
IoT sensor. Just prefacing what you're saying.
Yeah,
Everything
yeah.
you're saying can't happen.
Yeah.
But that smart sensor has to know, hey, the last 10 parts I had were in this range.
Yeah.
You're outside that range. Now you can send that
Yeah.
data where you need to send
And the thing is, I think that anything that happens inside that zone should be reportable.
Mm-hmm.
And if that means investing more money and more time into smart grippers, into grippers that do understand that deviation,
Yeah.
to get that data out of the machine, to understand that, hey, this is how you build a better product, then, that's stuff that has to happen. Yeah. And then, like you said, the KPI thing is, for me, I like dashboards. The world I work in, dashboards are king. Knowing my data, knowing what I have to fix on a daily basis, knowledge is power, right? Mm-hmm. And I want to give as much of that as possible. I want it to be able to also sound an alarm and say, guess what? I've got a problem going on here, and I've sent you a notice. Now I'm throwing an alarm. Now I'm throwing a verbal alarm, like a bell or something like that says, hey, guess what? I'm having problems. Which, where do you do that?
Yeah. If we're using the smart devices, it'll text the person.
Right, exactly.
Or it could call a person, however you...
I'd love to see how that one works.
We use it right now for in time we have an event that could possibly be a fire.
Yeah.
So the systems are there.
Right. I just really wonder if a robot's going to call you if you hit collect or not.
Well, I guess the robot would trigger an event, and then the other system would do all that.
Because I guess if it's a KUKA robot, does it call you with a Chinese area code?
Yeah. Good. Long as you get the message.
But the thing is, the jokes aside and stuff like that, it's how do I get the data to the people who need it the most? Because, like you said, the historian data, the stuff to build better lines later is the data that needs to be stored in very tight controlled areas, because that is the data that I am going to build a digital twin off of.
Yep.
I'm going to take all of that data and I'm going to build a digital twin. I don't think, and it might be wrong of me, it might be dumb of me, it might be whatever, that we should stop building lines like we have been and stop using robots like we have been in the past 20 to 30 years and finally invest in this technology that's coming out where it's digital twin. Let us build your system in digital twin. Mm-hmm. Siemens has already got it. ABB's got it. Fanuc got it. All these people have got it. For love of Christ, buy it. If you have the robots and you have this technology, own the software. Mm-hmm. Because then you can take all the data that all of your machines are making and send it to your digital twin, so you can actively watch things happen in real time. Mm-hmm. And you can get the statistics out of that. You can get real time, monitoring out of a digital twin. And you keep the data for when you rebuild something and you rebuild the line. Oh, I need to add a robot here. That digital twin's going to go, no, you're not. Mm-hmm. You think you are, but you ain't. Yeah. Because it's not going to work. Or, hey, I'm going to put an automation cell right here, and it's never going to work the day you install it. Mm-hmm. Or it will be, but you're going to spend hundreds of thousands of dollars putting this cell in that's never going to get used, or if it does get used, it's going to crash more times than it's worth. So, the thing is a digital twin will tell you that, so you don't end up having to play real-time experiments. Yeah. Because last time I checked, we're not in the business of playing, Crash Bandicoot.
Unfortunately, that has not changed since the 80s as far as people's approach. What they do learn is that you can integrate processes, and you can do, say, what 2 lines we're doing into 1 line. That's how you integrate new automation. Mm-hmm. New technology has a impact on that. Yep. They also learned that, okay, hey, we didn't have enough utilization in the cell, so we couldn't meet our jobs per hour. We didn't have technical availability because this robot had, because of a design flaw. Maybe it was a drive. It was a drive flaw when you're running at a certain voltage. Mm-hmm. Well, they didn't have enough data at the time, but now they do, and they know, well, hey, we need to have a more robust the manufacturer. So the manufacturer gets this information.
Right, I agree with. I think that, all the data you collect from your production line, that's not production relevant data, that is systems relevant data, should go to a central repository where your business partners can pull from and view to see, hey, is there an issue? For example, if you're paying for, say, ABB support or KUKA support or FANUC support or whoever support, you should be able to provide them with the data in real time. It says, hey, come down and pull this if you want it. Hey, we're having this major issue with our robots. Can you take a look? They'd pull that data, which most companies do. Most companies will send all their data to the cloud so you can go view it. As far as for those type of environments. However, I think that, it's like, hey, there needs to be design reviews built in this process where, hey, guess what? We've used your robots for a year. Let's do a design review. Let's take a look at our data versus what your data is, and evaluate that to make sure we're on a correct trend path. Because now you have manufacturer supporting manufacturer, who's then going to support the end user at the end of the day, which is going to be the manufacturer they're supporting. And then, they make that vicious cycle as that data comes back around, and you get this from all of your people. So everybody builds better robots. Everybody, builds a better mousetrap. Because the thing is, what is a robot? Mousetrap. And because everybody's going to buy one. And you kind of build that better mousetrap. But the thing is at the same time, you give your engineers from those companies access to your digital twin, so they can actively see, okay, cool, this is what's going on. Now I can kind of see why this is happening. Maybe there's a little bit too much rotation here. Maybe we need to optimize in these locations. And they can do that digital optimization before even coming on site and actually validate, does that data make sense?
And for me, I don't have a problem with sharing the data, but I have zero trust with anybody that's not in my company.
Right. And
so
the thing is remove
to another digital twin,
yeah,
and they can have access to that through a DMZ.
Right.
Because there is no trust, because the blockchain can be compromised, or the products themselves can be compromised before they enter your factory. So for me, I'm just saying there's a precaution. Do not allow direct access for anybody that's not in your corporation to be in your networks, period. You can make another instance somewhere in AWS or whatever, and they can access it through Kubernetes or, through a container. That would be the only thing I would add there. Off-site it from your system. It can still be real time. It's just it's no connection. You can have access to this repository, but you can't have access to my digital twin.
Well, the thing is that's where a lot of the digital twin technology that what Siemens is using and a couple of other guys are using, and NVIDIA actually did it with them, is they have two different versions. They have a customer and a supplier digital twin, where it's still on your environment, which we call in the regular IT world. It is the customer interfacing environment or your supplier interfacing environment, which is an environment outside your environment that has no back traffic into the organizational's networking process. However, the traffic flows out, does not flow back in. But the thing is when Siemens and NVIDIA did this, they sanitized the data when they send it out. So once that secondary digital twin doesn't have product information attached to it. And you can see robot movements, but you can't see what the product is. So they sanitize all of that data, right, and they also sanitize the IP addresses. So now all the IP addresses are sanitized. And
so for me, unfortunately, I understand all of that, but I don't trust NVIDIA. I don't trust Siemens, because all of those jokers been had by the people that are a lot smarter than them, which is the hackers. The hackers will figure out a way one day. That's why I'm saying you make sure the umbilical cord is not connected. There is a way to get real data in real time sent to an offset system, and you only talk to the offset system, and then they can talk however they want to talk to that system. And I don't care what NVIDIA says or Siemens says, there will come a day they'll say, oh, we made a boo-boo. In the firmware, we didn't account for this, and it's a way to gain gain access to the system. And we've seen it.
My
thing is, I've seen it with every person that said you can't do this.
Right. But and the thing is, what we start seeing is the fact that, especially with like how they did it, the only reason why I say that's where you can install it is that's where what we've seen installed before. However, yes, you can install it. You can install it on the partner network on their machines and pipe them data. And then guess what? You're tooth and free at that point. All you do is create a pipeline for your data, and you're done. Yeah. So you can do that, and they'll still talk back and forth via certificate. So the thing is that type of stuff is there, and I think that's something that needs to be used more of because of the fact that there's so many downtimes globally for stuff that could have been prevented. That may have been an optimization issue that was not caught by the supplier. Now the supplier can check it, see if things were optimized, things were going on. But what I would do is also take all this data that I'm, collecting and drop it into a system where I can use a version of digital twin, not digital twin itself, but a version thereof, where that allows me to do virtual commissioning in virtual building on site. So I set up an office in my shop where I have screens and stuff like that set up, kind of like a VR instance or a simulation instance, where somebody can go in there and code and set up these robots and stuff like that in a digital commissioning world. So they can kind of test everything using the digital twin of stuff that's already in action, and you're just pulling data, and you're on site, so you don't have any, data, encryption issues, and there's no way for that data to go back to the line.
I mean, in general, like I said, if you're doing virtual commissioning, there's no need for the person to be on site because basically you're just doing optimization after that.
Right.
You should be able to take whoever's thing and put it in your system, set it up, and then go there. Now, on site, if your people want to do, we want to do testing because we had this data that we want to do for next gen stuff, then that's optimal thing to do.
I think even like a simulator, because I think something like that, you put up 8 freaking 70-inch TVs and have a entire simulation.
It would be good for training too. I'm just saying, like on site, that's the way I would use it. But in general, from what I'm seeing, from if we're saying in the future, most plants are not going to do their own commissioning on large scale. They may do smaller jobs, but it would be good for that.
And the thing is this is where I also want to look at the fact of using this data to also influence the training pipelines. So I can take this data and turn around and use it for training my local techs, training the individuals that are working on my line day in, day out, day in, day out. But it also allows me to take that same data and feed it back to the, say, the builders of the robots or the builders of technology, and allow them to influence their curriculum a little bit. Say, hey, this is what we're seeing in the real world. You might want to influence here. Or, like what we've talked about many, many, many times before, is I take my data, I sanitize my data, and I use it at the community college or technical or the trade school level to adequately train the next generation of robot maintainers and of the skilled trades professionals that are working with this thing, because now they get to train on real world data and real world applications while they're in an environment. So if all these companies, so if you look at like automotive manufacturer example, Mercedes, Honda, Toyota, Ford, Chevrolet, and all the GM products, get together, pool all of their data, the robot data and stuff like that, into one pool, and use that at the trade school level to allow people to learn on real world data on how to troubleshoot these robots. There you go. For example, you walk into a trade school and you have a Yaskawa robot, you have a KUKA robot, you have an ABB robot, you have a Fanuc robot, Kawasaki robot, and if you really want to, you can throw in a couple other, other ones in there. Mitsubishi, I think, if you're in, not in the U.S. But the thing is you take all this data and you throw it together, and now you have real-world data for every single one of those robot brains. So now you train the technician through the certification process, through the associate's degrees, or through the your regular certificate on data that is coming from the real world to make it relevant.
So in general, all robots are the same. The only difference between any robot is language.
Right.
Like that, there's no difference between a KUKA, a ABB. They will all have the same type of faults.
Right.
They may call it something else. The jargon may be different, but it's basically going to be the same thing.
Yeah, but
it's a movement fault.
Right. And the thing is, for me, it's why not use real world data for that though?
Yeah, but the real world data is just giving scenarios.
Right.
It is nothing different between any robot when it comes. The troubleshooting part of a robot, and I've been doing this for 20 years, has nothing to do with I need a scenario. Is it? It could create a scenario.
Right.
The same fault that can happen on an ABB robot will happen on a Fanuc robot. I can have a robot fault with motion. I can have a robot fault where a component fails.
Right.
A board goes out. A drive goes out. But then you have things specific to application.
Right.
So it would be scenarios. You would use it for what they call problem-based
training.
Yeah. So it would be perfect for that.
Yeah.
But like mechanically, they're going to be set up different because they use different approaches. So you would have to have that CAD CAM for that robot.
Right.
And it would be good for that. But I mean, like in general, when you're teaching robotics or teaching a person to work on robotics, it should be, hey, what are the things that are identical to each?
Yeah.
And what are the things unique? Then you can take those unique things that's with a ABB robot and do exactly what you said, based on scenarios, based on the CAD CAM, based on this is unique to this electronics in this robot.
Right.
And then it would be good for that. But I would generally try to teach people.
Yeah, it's a standard across the board. Yeah. And the thing is for me, how we used to teach it in the Marine Corps is, we used to call it something called SDT. So it's situational derived training. So I take a situation that I'm now thrown in, and I would derive training from it. So pretty much what it would be like, hey, I'm doing this week. I'm going to be focusing on faults that have been seen. We know they're all the same, however, that have been seen with, say, Yaskawa. Okay, cool. Let's load all the Yaskawa data, for these people. So, but the thing is now I'm going to put that robot in default mode. I'm not going to show you what my faults are, but I'm going to give you a application where you can go search through the logs and you can see what you can find. And the thing is so now I put you in a situation where now you have to go find it, but I'm going to put it in a fault state. And the same thing you could do that with all of them, all the way across. But you're using real data. You're looking at the data that's been derived from that exact situation. So you put it in that same exact fault situation and see if they can derive the training from it.
And for me, if we go into Industry 4.0, I don't even want people to go through logs. I want it to just pop up. Hey, this is the problem. I want what Windows give you when it complains to you.
They tried to do that when they made Windows for Dummies. People so screwed up.
But I'm saying with that, why if I'm searching for gold, do I have to pull a metric ton of gravel? If I can identify where the gold is, how about I just get the gold and not go through a metric ton of gravel? That's the problem with these systems. The system should be intelligence.
Right.
Because the robot's going to be the intelligence. I'm not worried about making a person a SME. The SME should be the data analyst. The data analyst should understand the data.
Yeah.
And what I mean by that is, that's okay to have that type of training where they go look in the logs.
Right.
There's nothing wrong with that. I'm just saying, when you're trying to teach them this type of fault equals this type of fault equals that, then the system should be smart enough to at least say, hey, you were here.
Yeah.
Hey, you're located here in South Carolina. Or hey, you're located here in Virginia. Or
Right.
wherever you are. Oh, well, hey, you might be located in between California and New York.
Well, that's not wrong.
I'm just saying. I'm saying we should, if we do the whole thing we were talking about the Industry 4.0.
Yeah.
These are the things that should happen.
Oh yeah, definitely.
Even with the training, and then you should have a scenario where, hey, it doesn't know what it is. Now you have to go look at the law.
Yeah, exactly.
You have to make the decision now.
You should always go back to what is old school. What we used to call paper and highlighter. Is go back to, because we when I did Intel for a living in the Marine Corps, we had smart systems that mapped all these people and the who's and the who's. Some of us still preferred to print out the report and highlight the damn thing, because guess what? It's not wrong. What my thought thinking was, it wasn't wrong. It was, this is what I'm thinking. This is my gut's telling me, and so you waste a little bit of paper, you waste a little bit of ink marker, but the thing is, it teaches you how to do things the old school way. I think before you get given the fun tools, you get taught the old tools first.
Yeah.
Because the thing is, and this is why where Industry 4.0 can be a little bit of fun, especially when you start dealing with robotics and AGVs and all this other shit, is you have the ability to either teach somebody, and especially when you come down to training, is teach somebody the old way of doing things, because now you still have all your logs, you have all this data, stuff like that. Then you have the new way of teaching somebody, where it's like, hey, guess what? You may incorporate this into the field. Here you go. But the thing is, because sometimes these technicians will go to plants where they don't have the new thing because they haven't bought it yet. They don't even have the middle of the road thing. They have the, hey, guess what? We're still over here working on punch cards.
Well,
but
if you're using Industry 3.0, then do what you're saying. If you're using Industry 4.0, I disagree. It's not necessary.
But the thing is,
should understand what he's looking at.
But the thing
he's
is,
not an analyst if he doesn't understand that.
But the thing is I think that it needs to be trained like that across the board.
I don't think it's necessary. I think, just for me, I don't think that's necessary. I think, they need to know schematics.
Yeah.
They need to know basic electrical things, yes. But like having a guy, teaching a guy, having a guy trained to go through and basically do Excel sprawl.
Yeah.
It's not a good thing. That's not teaching an analyst to be an analyst.
Well, the thing is that's when you start using systems like Kibana and stuff like that, and go Ruler. But using systems like Kibana and stuff like that, and teaching them how to search for it, teaching them basic Boolean logic searches, where it's like, oh, I have a problem with this robot. Here, let me look at this robot and see things screaming at me.
Well, that's part of the analysis, but in general.
But the thing is, I'm not teaching you how to do in-depth analysis. I'm not teaching you how to go in here and the log message is written wrong. I'm not teaching you to be a data guy that's walking around here with a pocket protector. All right, I'm teaching you how to be a data guy with a wrench. And so pretty much it's, hey, look at that. Okay, yeah, that's wrong. Okay, cool. Now go fix it.
So from my experience, that generally doesn't work on the shop floor because of the people you have working.
Well, guess what? We're getting above and beyond the age of where freaking the guy fixing a robot's a dumbass, and we're going from basic wrench banger to we're going to IT based, because things are turning Industry 4.0.
And then an analyst is not going to take time going through a log. He's going to have a system that does that for him.
Right.
He's going to write a script. He's going to automate that.
Right.
That's what a good analyst is going to do. He's not most data scientists are not going and manually going through and searching. They have a script.
Right.
Run script. Now, they may put those parameters in that script to do that, but they're not doing that.
No.
So for me, that's what I'm saying. Like, be careful with bringing old stuff with new stuff. Mm-hmm. Sometimes you need to leave those old techniques in the past. So like using drum switches was a good idea back 20 years ago.
Yeah.
But it's not now. It's not necessary. We have technology that can do those things. So I believe in, yes, the guy should know how to do things if the system's not working.
Yeah, I think just, and the thing is when I mean train them on how to do it, it's a bare bones, hey, guess what? This is a crash course. This is a drive-by. You may see this.
Yeah.
I'm not going to sit there and spend 3 or 4 weeks training you how to do it. Yeah. For the love of God, I know that's not going to happen. I'll be happy if I get the bandwidth. But the thing is, it's hey, here is 8 hours or 14 hours, 2 days worth of training on this is how you look at logs. Bare bones, this is how you look at logs, just in case your fancy system shits the bed. So you understand how this stuff works. How if you don't have a data guy, if now, guess what? You become the maintenance data guy. because your company is so damn small and so misorganized and mismanaged that guess what? Now I have a tech being a data guy.
That's what we're going to.
Right.
That guy is going to become an
Right.
analyst, not a SME. The
Right.
SME is going away.
Right.
The analyst is coming.
Yeah. So the thing is, let me give you 14 hours of instruction, 2 days, 2 contact days on this is how you look at logs.
Yeah. I mean, you can do that, but like I said, for me, from my experience, from what I've seen over time, those guys forget that stuff.
But
if you teach them how to use those systems,
exactly,
then that's a different.
That's what I mean. I mean, the thing is when I'm talking about log analysis, there's a difference between, hey, guess what? I'm looking to make sure I got my T's and my I's dotted and all this other stuff, right? The old school way of doing log analysis doesn't exist anymore. We know this. But the way of how to use like Kibana and these systems, it give you 14 hours of contact training.
That's using the
on
tool.
Right, on Kibana. This is how you do Boolean logic. This is how you save searches. This is how you do this. I'm not, and then look for the things you're looking for down the bottom. So I'm not saying open the log up and evaluate every damn line because that ain't ever happen. But look for what you're looking for. If I'm looking for robot 1, 2, 3, 4, fault equals this. Okay, bing, it's not there. All right, cool, we're good. Yeah. If my fancy system on the other end fails, I need to be able to run that Boolean logic query, the safe search that I have already saved, to go look and see if it's there.
So for me, like I said, once again, I'm going to disagree a little bit. I'm going to teach him how to write a script, and the script going to do everything you just said.
Yeah.
Because that's what he
Well,
needs
guess
to
what?
do.
Kibana can't do that, and it's still safe search.
It can't do Python.
Run safe search.
Python, I guarantee you.
No, it cannot.
It can offload that data and do everything you want to do with Python.
CSV.
Whatever. Python can do that. I've done it with Python.
Yeah, but the thing is now I got to worry about teaching somebody who has no programming skills how to program robots.
Yes,
program
guy that you're
Python.
talking about in the future in 4.0 will already have that skill set.
Yeah,
it's coming. We're not talking about. We talking 20 years from now.
Right.
These wrench turners that you're talking about will not exist.
Right. Exactly.
You're talking about kids that's already going to be exposed to that stuff on the high school level.
Yeah.
So they're already
TikTok
going to
generation.
be. It doesn't matter. Some of those kids going to be more than TikTok. Some of those kids going to be interested. Some of those kids going to become the next Elon Musk. Some of those kids going to be like, "Ooh, I'm really interested in this. This really interesting."
And that's what we hope
And they're
for.
going to dig into it, and they'll already have the skill set because one day we'll wake up in this country and say, "Hey, we got to train our people for the role." So what I'm saying is you can automate almost 99% of everything that you manually trying to get somebody to do. You can. It's the future.
Right.
You should do that because it's going to be a one guy in a small mom and pop shop, or it's going to be one guy that's got 10 roles. You have to learn how to automate because what I see is we got all these systems that we use, and everybody's using Excel sheets.
Yeah, and the thing is I'm not going to think or have any stretch of the imagination that some people are going to be able to learn Python. I know that.
Yeah. I mean, we're just saying always saying it's automation. It doesn't have to be Python. We're saying that you're automating all the things that you taught that person.
And the thing is, and this is where, like, if you use Kibana and you use Logstash, if you use Kibana correctly, Kibana can do automated message processing.
Well, there you go.
Meaning that it can do alerting for you.
Even better.
And then, and the thing is Kibana also has your ML built into it. Mm-hmm. So the thing is, if I taught you 14 hours of, hey, contact time, right? Mm. Of this is how you set up an alert in Kibana. This is how you do it. This is how you create your search in Kibana. Yeah. This is how you create your dashboard in Kibana.
Yeah,
the thing is all I'm doing on the other end. So now I've already taken care of Plan B because if my alerts work, I never have to open this system again.
But it's the tool. Knowing how to use the tool, whether it's automatically doing it or you're giving it a new filter.
Yeah, that's what I'm getting at. Is learning to use the tool before I give you the fun, the tool on the other end.
I agree with that.
I think we're saying the same thing.
No, I agree with that.
We're just looking at it at 15 different directions here.
No, I see what you're saying.
But the thing is again, I still think that we need to take all of this training that we want for the robotic side of the house and drag it down to the lowest level denominator. I think for the love of anything is I should be able to take Kibana or some of the other new ones they come out with and bring that down to a high school level and teach the kids who are in the math and some of the computer science programs that they have and teach them how that works.
Or just make it mandatory that everybody. Just
I can agree with that too.
MS, like they have to learn how to use Windows. You make that part of a. Everybody has to know how to do some type of analysis.
Yeah.
It doesn't mean you have to take that job, but you have to have that skill set.
Yeah.
So that skill set becomes something that is part of the curriculum in the whole school, and we don't give an option of, hey, you get the basics.
Yep.
Everybody get the basics of
I can agree
how
with
to do that.
I can agree with that. And, I think that, for us, I think that, I think that brings us to the end of tonight. Especially talking about, Industry 4.0, robotics, and especially how we see it changing things, because you never know what you're going to get. We don't know how it's going to look in 10 years. We can spitball, we can hope, we can dream. We won't know it until it gets there, and God knows it could look different.
It may get to 4.0 and go right to 6.0. Who
Right.
knows? It may just jump straight to.
Or 4.0 may get here and say, I don't want any part of this, and do a U-turn. You never know what we're going to get.
Yeah, but I do think that now that they have so many intelligence-based things, and they're doing so much connectivity,
And
it's going to be hard to turn it around.
Yeah. And I think that with the generation we have coming, and the kids and the adults that are coming up that want to learn, that want to be invested in this type of stuff, that want to learn new things, that taking an hour and some change to listen to us freaking ramble, but is wanting to see this through, and they're going to be the ones that are going to build that technology. Mm-hmm. They're going to be the ones that build that after we're done, retired, and sitting back looking at it going, ooh, that's cool. Yeah. And we see what they're doing on YouTube, and the thing is cool, that's really nice. They're out there at Industry 8.0 and figure that stuff out, so now we got people with the smart glasses and stuff like that, evaluating stuff, kind of like what Fanuc started doing. But thing is, we're going to see that. We're going to see people kind of get interested in it and really spearhead an effort, I think. But, I just want to, take a moment and say thank you to everybody. We're at 2,888 all-time listens. We're 200 or so away from, actually 100 and something away, almost 200 away from hitting 3,000. So, you know what? I say thank you. So you've all, go take a look at Vulcanara.com, Vulcanara 3D. Printed Heritage, the blog. We're adding more and more stuff out there. We're kind of redoing a lot of stuff. We have some really interesting and cool stuff coming. Hopefully within the next couple of months, I hope we'll have a pretty cool announcement that we get to make. That'll kind of drive how some things are going. Take a look at some of the stuff. If you're listening to this on YouTube, go ahead and subscribe to the channel for me. Let me know what you think. Leave a comment, leave a like, do something. And then also, I'm starting to do a lot of stuff where I'm doing the videos. I'm putting out a lot of videos now. Once every Monday, Wednesday, and Friday, we're doing a short of a STEM legend. So we're going to start doing that. We're going to go through our STEM legends. And then we're going to start working through the automotive legends and also the legends of the automotive aftermarket. So we're going to keep doing that, and as we go through, I see some people have actually enjoyed them. So I say thank you for that. If you can, go ahead and like and subscribe, and we highly appreciate it. So I thank you, and I'll turn you over to Ed.
Oh, we appreciate you guys listening. Appreciate the support. As always, we like talking about technology and things that are developing. A lot of it is based on our prior experience and some of the things that we've learned, just from examining the new technologies and things. But we would like to hear from you guys and see if you guys have any opinions, or if you guys have any ideals or anything that you want us to touch on or talk about, or if you guys want to just reach out to us and just have a chat, we can do that too. So appreciate it, guys.
All right, y'all. You have a good one. All right, bye. That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break.
We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.